Hello, quantum enthusiasts. Welcome back to our channel. Today, we're stepping into a realm that's as mind-boggling as it is fascinating. We're talking about quantum physics, the science that takes us into the incredibly small world of atoms and particles even tinier than atoms. It's the science that makes our modern devices possible. If you're new here and intrigued by the mysteries of the universe, don't forget to hit that subscribe button. So, buckle up, because things are about to get a little uncertain. Quantum physics. It sounds like something out of a sci-fi movie, right? But hold on to your seats, because it's not just the stuff of Hollywood. It's as real as the air we breathe, and it's happening all around us, all the time. Imagine the tiniest building blocks of the universe, so small that they're almost impossible to comprehend. These minute particles, the atoms and the subatomic particles, are the actors of this quantum stage. Quantum physics is the study of these particles, and the bizarre rules they follow. These rules are so strange that they often defy our everyday intuition. For instance, particles can exist in multiple places at the same time until observed. They can tunnel through barriers that, in the macro world, would be impenetrable. But why should we care about something so small and seemingly abstract? Well, it turns out the world we know and love wouldn't exist without quantum physics. The technology we rely on every day, from our smartphones to our computers, even the sun that gives us light and warmth, all rely on the principles of quantum physics. So, the next time you send a text or enjoy a warm, sunny day, remember the tiny particles and their weird quantum behavior that makes it all possible. In simple terms, it's the science of the very, very small, things like atoms and particles that are even smaller than atoms. Now let's talk about one of the most certain things in quantum physics, the uncertainty principle. This principle, first introduced by the German physicist Werner Heisenberg in the early 20th century, is a cornerstone of quantum mechanics. But what does it actually mean? Well, imagine you're trying to take a photo of a hummingbird in flight. You can either get a crisp, clear shot of the bird frozen in mid-air, or you can capture the blur of its wings flapping at incredible speed. But you can't do both at the same time. This is a rough analogy for the uncertainty principle. In the realm of quantum physics, the uncertainty principle states that you cannot precisely measure both the position and momentum of a particle at the same time. The more accurately you know one of these values, the less accurately you can know the other. It's not due to any limitations in our measuring equipment or our techniques. No, this uncertainty is a fundamental aspect of nature itself. It's an inherent fuzziness in the fabric of the universe, and this isn't just theoretical. The uncertainty principle has real-world implications. For example, it's the reason why electrons don't just spiral into the nucleus in atoms. If they did, we wouldn't be here to talk about it. Now, you might be thinking, wait a minute, that doesn't make sense. I know where I am, and I know how fast I'm going. Why don't particles? Well, that's because particles aren't like tiny billiard balls. They're more like fuzzy clouds of maybe. In the end, the uncertainty principle tells us that the universe isn't as predictable as we might like it to be. It's not just that we don't know everything. It's that there are things we can't know, no matter how hard we try. As Heisenberg himself put it, the universe is not as simple as we would like to believe. So, to wrap up, it's like trying to watch a movie and read a book at the same time. You can't fully focus on both. And that's the uncertainty principle in a nutshell. Next up is quantum entanglement, or as Einstein liked to call it, spooky action at a distance. Now, doesn't that sound like something straight out of a fantasy novel? But hold on to your hats, because this is science, not sorcery, although it's just as enchanting. Quantum entanglement is a phenomenon that's as peculiar as its name suggests. It's a kind of connection that forms between particles, a bond that transcends space and time. Imagine two particles that have interacted with each other in some way. Once they're entangled, the state of one particle will instantly influence the state of the other, regardless of the distance between them. Think of it this way. Suppose you have a pair of gloves, one left-handed and one right-handed. If you pack them into separate boxes and send them to opposite corners of the world, you'll only know which glove is in which box when you open one of them. But the moment you open one box, you'll instantly know what's in the other box, no matter how far away it is. That's quantum entanglement for you. What makes this phenomenon even more fascinating is that it isn't affected by the distance between the particles. They could be nanometers apart or light years away. the entanglement remains the same. It's as if these particles are telepathically linked, a notion that Einstein found so unsettling, he described it as spooky. But quantum entanglement is more than just an oddity of the quantum world. It holds potential for advancements in computing, cryptography, and even teleportation. It's not just spooky, it's spectacular. To put it in a fun perspective, quantum entanglement is like having a pair of magical dice. No matter how far apart they are, if you roll one and it shows a 6, the other one will show a 6 too. And just like that, we've rolled our way through the captivating world of quantum entanglement. Remember, in the quantum realm, things are not as they seem, and that's what makes it all the more intriguing. Finally, let's touch on quantum computing. Now, this is where things get really exciting. You've probably heard of regular computing, right? Ones and zeros, bits and bytes. That's the language of our everyday computers. These bits are like tiny switches that can be either on or off, representing a 1 or a 0. But what if I told you that in the world of quantum computing, these bits can be both on and off at the same time? Sounds like a magic trick, doesn't it? But it's not. It's the magic of quantum physics. These quantum bits, or qubits as they are known, operate under the principle of superposition. Essentially, superposition allows these qubits to exist in multiple states at once, increasing their computational power exponentially. Imagine having a magical coin that, when flipped, doesn't just land on heads or tails, but can land on both at the same time. That's what a qubit is like. And just like the magical coin, a qubit can perform multiple calculations simultaneously. This means that quantum computers could potentially solve problems that would take classical computers millions of years in just a few seconds. But it's not all smooth sailing. Quantum computing is still in its infancy, and there are many challenges to overcome. For one, qubits are incredibly sensitive to their environment. Even the smallest disturbance can cause a qubit to lose its quantum state, a phenomenon known as decoherence. Despite these challenges, the potential of quantum computing is vast. From revolutionizing drug discovery to optimizing complex systems, the possibilities are virtually limitless. Quantum computers could even help us unravel some of the universe's greatest mysteries. So, to sum it up, quantum computing is like having your cake and eating it too, but in binary. It's a field full of potential, full of challenges, and full of excitement. And who knows? Maybe one day we'll all have quantum computers on our desks. Until then, we'll just have to wait and see what the future holds. That's all for today, folks. We hope you enjoyed this quantum journey. We've been on quite an adventure, haven't we? From the minuscule realm of atoms and particles, where the laws of quantum physics reign, to the paradoxical uncertainty principle that challenges our conventional understanding of certainty. We've grappled with the concept of quantum entanglement, an eerie phenomenon that seems to defy the constraints of space and time, linking particles in a way that's truly mind-boggling. And we've glimpsed into the future of technology with quantum computing, where binary restrictions are tossed aside to make room for superpositions and the potential of performing multiple calculations simultaneously. In this whirlwind tour, we've only scratched the surface of this fascinating field. Quantum physics is a vast and complex topic, filled with paradoxes that challenge our understanding of the universe. It's a science of the very small, yet it has profound implications on the very large, our world. Remember, this journey doesn't end here. Quantum physics is an ever-evolving field, with new discoveries and theories cropping up regularly. Every question answered opens up a myriad of new ones, and every theory confirmed paves the way for more exploration. The beauty of quantum physics lies in its mystery and the endless possibilities it presents. Embrace the uncertainty, let it fuel your curiosity, and drive your quest for knowledge. The world of quantum physics is a world of wonder, of imagination, of infinite potential. It's a world where the impossible seems possible, where the tangible becomes intangible, and where the known and the unknown coexist. So keep probing, keep pondering, and keep pushing the boundaries of your understanding. There's a whole quantum universe out there waiting to be explored. And remember, you don't need to have all the answers. Sometimes it's the questions that are more important. So, stay curious, keep asking questions, and as always, keep it quantum.